Well, hello, everybody. So, today's my first day back from a seriously bad bout with the flu. I would much rather be making math videos than dealing with the flu like I have been. But anyway, today it came up to solve this kind of question. Here it is in my math lab where we have various questions about lines. Okay, so we're given a line that has different points on it, or maybe the slope of the line is known, or something like that. Okay, so let's talk about how to do that. So first of all, lines, as far as there being something predictable about a line, is its equation. The equation looks like y equals m times x plus b. M is some number which measures the slope of the line, or is the slope of the line, and b is some other number that is the y-intercept of the line. The y-intercept of a line is where it hits the y-axis. Okay? Now, so we'll just have to take it as a starting point that the equation of a line will be y equals mx plus b, where m and b might be something that we're supposed to figure out somehow. Okay? So let's take this example right here where I've drawn a line and I've labeled two sample points on it, and I'm not saying this is to scale or anything, but it's a line. You look at it, it's straight. Okay, and I got this point right here where it's 1 for x, negative 1 for y, and this other point over here where it's 2 for x and 6 for y. And then my question is, what's the equation of that line? Okay, so here's how we go about that. Well, first of all, I know that's what the equation looks like. I know that the form the answer takes is y equals mx plus b, because that's the way that the equation of a line is going to look. Okay? But I start by doing this. I find the slope. And the way we find the slope is we take the second y coordinate, which is 6, minus the first y coordinate, which is negative 1. So notice how that says 6 minus negative 1, over the second x coordinate, which is 2, minus the first x coordinate, which is 1. So I get 2 minus 1. Okay? And then I just reduce this number, and I get 6 minus negative 1. That's going to be 6 plus 1, that's 7, and 2 minus 1 is 1. So the slope is 7. Now, that gives me a partial answer. I know that the answer, being the equation of a line, looks like y equals mx plus b. And if I figured out the slope is 7, then I know that m must be 7. So it's y equals 7x plus b. Now, I still don't know b, though. Okay? So I'll give you this as a partial answer. All right? Now, to give the full answer would be to give this full equation, and I'm halfway there. I know m is 7. I got to find b. Here's how we can find b. We can use either known point on the line to find b. Meaning, here's the line, and I know that it has those 2 points on it. 1 and negative 1, and 2 and 6. Okay? So, I can use either one of those and plug the x in for the x and the y in for the y and solve for b. So, I chose this one, 1 and negative 1, which amounts to x being 1 and y being negative 1. So, I take my partial answer right here, and I put those numbers in. I put negative 1 for y, and I put 1 for x, and then the only thing left at that point is b, which I solve for, and I get negative 8. Okay, so there's your final answer. The equation of the line that goes through those 2 points is y is 7x minus 8. And that's all from the assumption that the equation must look like this. So first I find the slope, I put that in the equation, then I use either one of the known points on the line to find b, the other number. Okay? Alright, now let's do something a little bit different. This sounds kind of like the one I just showed you, but it's a little bit different. I'll have a look at it. It says find the equation of the line that has a slope of 8, and it goes through the point negative 5 for x, 5 for y. So this one, I guess, is a little easier. It's like it's a step ahead of the last one. I already know the slope. So wouldn't a partial answer be y equals 8x plus b? I mean, because that's where the slope goes, and if you tell me the slope's 8, then it's got to be y equals 8x plus b. Now, I don't, with that information alone, I don't know what b is, but we could use that, we could find that in the same way we did the last one. In the last problem I just showed you, how do we find b once we figured the slope? I said we can use any known point on the line to find b. Okay, so if I know this point is on that line, then I know that I can put -5 for x and 5 for y. That's what that means. So I do that, and I get like this. Okay, do a little math. I get -40 right there. I aim to find the b, so I try to solve for the b, and I move the 40 over, and I get b is 45. So I got final answer is y is 8x plus 45. So this one even is maybe a little easier than that last one. When you told me the slope right off the bat, then I know that number's 8, and it's just a matter of figuring out the b with the other known point. Okay. All right, so let's do one last one. This being about the intersection of lines. So sometimes we might have two lines, and we want to know where they intersect with each other. And that's probably not a mysterious concept. Where is this point? It might be that two lines cross each other, and I want to know the spot where they intersect. Now, the method for figuring out that point of intersection, that spot where they intersect, is fairly straightforward. We just set the two equations equal to each other. So you see how this one is y equals x plus 1? Okay, that's my first equation. And this one is y is 8x plus 45. That's my second. I just set them equal to each other, and I solve. Okay. So if I try to solve this, I'll move the 8x over there. I'll get -7x. I'll subtract the 1 over here. I'll get 44. And then if I divide by -7, I'll get 44 over 7. -44 over 7. Now, I know the x coordinate of where these two lines intersect. So there's these two lines. All right, so I know the x coordinate is -44 over 7. Okay. Now, every point on a graph has an x coordinate and a y coordinate. So next would be to find the y coordinate. But you see how these equations, like, they both have an x and a y? I can take my found x coordinate and I can plug it into either one of these. Either one. Doesn't make any difference because we're finding some common point of intersection. Plug into either of those known equations and find the y. Probably you'll take the one that looks the simplest. I think this one, y equals x plus 1, is the simpler of the two. So, here, that's what I'm going to use. I'm going to take my known x value right here. I'm going to plug into that one, y equals x plus 1. Okay, so that'd be y equals -44 over 7 plus 1. Do a little math. That turns out to be -37 over 7. And so that's my y coordinate. Here's my x, there's my y. So these two lines intersect each other at -44 over 7 and -37 over 7. Okay, those aren't nice round numbers, but still where those two lines intersect. Okay, now I'm not saying this drawing is to scale or anything like that. I put this drawing here just to have you take in the concept that two straight lines could intersect each other, and what we're finding in this problem is that such point. Okay, so I hope the method seems fairly simple, that you just set them equal to each other. We might not get nice round numbers when we solve it, but that's okay. It might work out like that. As long as you don't make any miscalculations along the way, trust the method, even if the numbers look a little weird in the end.